One of the limits that you have to do on that Calculafs handout that we had this week about the boyfriend zero was this limit here. And we will learn later that there's a lot of important qualities about this limit. But right now, we're just trying to solve this thing using the limit rules and the any other algebra techniques that we might have learned for evaluating limits. So that's what we're going to do. The first thing I want to point out is that we can figure out the value of sine of pi over 3 from the unit circle. So rather than make things more complicated than they need to be, let's just make this the sine of pi over 3, which is the square root of 3 over 2. The other thing I want to do is go to our identities and transform this expression sine of pi over 3 plus h using the addition identity. So in case you've forgotten, that identity says if you have a sine of a plus b, you can write that as sine a cosine b plus cosine a sine b. And we'll do that with sine of pi over 3 plus h. And we transform this limit into this limit. Limit as h goes to 0 of, let's see, my a is pi over 3 and my b is h. So I'm going to have sine of pi over 3, which we already know is the square root of 3 over 2, cosine of h plus cosine of pi over 3, which I know is 1/2, times the sine of h minus, and then we just said this is the square root of 3 over 2, this sine of pi over 3. And that is all still divided by h. And then just at the bottom of this slide here, I'm going to simplify any of the trig functions that I can, any of the trig values. So limit as h approaches 0, sine of pi over 3 we said is the square root of 3 over 2. Cosine h is variable, I can't compute that. Cosine of pi over 3 is 1/2. That's terrible handwriting. Come on, man. You gotta slow down. Sine of h, and then we've got the minus square root of 3 over 2 on the end here. And remember, this is all divided by h. Now, as I transition to the next slide, I'm going to be rearranging some things. So I just want to draw in for you what I'm going to do. I'm going to switch the positions of these two terms. And so when I write this on the new slide, you'll notice that those are in different positions. And then there is a method to my madness, so I'll show you why I did that. So as you can see, I went ahead and switched the positions of those two terms. So I put the square root of 3 over 2 in blue because it moved into the middle position, and in red, the 1/2 sine of h, that's supposed to be an h on the end there, moved out to the end. And now what I'm going to do is I'm going to separate this fraction. So I'm going to separate on this plus sign right here, and I'm going to make two fractions, and I'm allowed to do that. So we will now have the limit as h approaches 0 of the square root of 3 over 2 times cosine h, that's an h, minus the square root of 3 over 2, all over h. Then I'm going to split at the plus sign, and I'll make a separate limit here. Limit as h approaches 0 of 1/2 sine of h all over h. Okay, now I do that because now on the right-hand side here, I can see that I'm going to have my constant multiple of the limit as h approaches 0 sine of h over h. And we know this sucker, the value of this limit, I should say, equals 1. So this whole thing has a value of 1/2 times 1, which is 1/2. And we're done with that piece. This guy over here isn't going to go down quite as easy. But you will notice that I have a common factor here of square root of 3 over 2 and square root of 3 over 2. So I'm going to go ahead and factor that out. And on this limit, I'll have the square root of 3 over 2 times the limit as h approaches 0 of cosine h minus 1, because I factored out the square root of 3 over 2, over h. And we still have the plus 1/2 over here. Now, the trick for this limit is that we are going to multiply by the conjugate on top and bottom. So I'm going to do cosine h. I'll squeeze it in here. I know this isn't great for your viewing pleasure, but it's easier for me to do it here. Cosine h plus 1 and cosine h plus 1. And when we multiply this through on top in the numerator, that's the difference of perfect squares. So as we wrap up this slide, we'll have the limit as h approaches 0. We still have this constant multiple square root of 3 over 2. In the numerator, we'll have cosine squared of h minus 1. In the denominator, I'm not going to multiply those together. I'm just going to put h times cosine of h plus 1. And then I still have the plus 1/2, as I mentioned. Now, we are so close to getting this thing figured out here. In the next slide, what I will do is I will use an identity to change this expression in the red circle, and all kinds of good stuff's going to happen. So let's transition to the next slide. As I showed you in the last slide, I was going to use an identity to change the value or change the expression in the numerator. So this guy used to be cosine squared of h minus 1, and that's the Pythagorean identity, cosine squared h plus sine squared h equals 1. And so when we solve for cosine squared h minus 1, that equals negative sine squared of h. So there's the new expression. And then what we like to do with these is to break that sine squared into a couple of pieces. The negative 1, I'm just going to factor out here. So this negative sign is just going to pop out here by this guy. So I have negative square root of 3 over 2, and then I'm taking the limit as h approaches 0, and let's write this as sine h over h times cosine h plus 1. And now, oops, and don't forget the plus 1/2. That guy's still hanging around over there. And now you'll notice that we've been saying that this limit as h approaches 0 is a 1. And so I'm just going to eliminate that part, and then really all I have to do is figure out what this limit is. I need sine of h over cosine h plus 1. Don't forget my plus 1/2 out here. And go ahead and do substitution on this, and we get sine of 0, which is 0. And on the bottom, I get cosine of 0, which is 1, plus 1, which is 2. So this whole thing is the 0. 0 times the square root of 3 over 2 is still 0, so this is gone. And the value of my limit, miraculously, is 1/2. Looks like I finished this video just in time for the announcements to come on. Having said that, hopefully this helped you see how we can struggle our way through evaluating this limit. What we're going to find in a week or so is that this limit is a special type of limit, and it turns into this really fast shortcut that we'll learn later. For now, enjoy working on your trig limits.